Let me start recording. All right. So welcome everyone. This session will be 60 minutes where Adrian will go through Trow.
Hopefully it won't be anywhere near 60 minutes. I don't want to take up that much of people's time.
Yeah, but
we'll see how long it takes.
This 60 minutes will include the maximum where you will be able to ask any questions or have any comments, or maybe you have some experience and you want to share your experiences, etc. By default, everybody is muted, so I just want you to know. If you have any question, please feel free to unmute yourself. We are not that many people here, so it should be okay to manage. Otherwise, of course, there is a chat box. You can post questions there, and I will be monitoring it during the time. Again, please don't be shy and ask questions. This session is for you to be able to dig deeper, and if you are interested in this topic, of course. So, don't be shy. And Adrian, please, if you want to maybe say something a little bit about yourself, maybe people don't know, and what brought you maybe to this project as well before you start.
Thanks, Teresa. Normally I don't really say much about myself because I always find that the worst bit of presentations, but when a speaker goes on for 10 minutes about who they are. But as a brief introduction, I've worked for Container Solutions for a long time. My official title is Chief Scientist. I am meant to look more at products and sort of research projects, and so that's what brought me to Trow and studying container registries, which I sort of feel is an overlooked area. Okay, I think I'll get started if that's okay.
Sure.
Can you see my screen?
Yes,
I can. Yes.
I did push present now. Is it working? Why is present not working? But you can see, I take it you see everything. You don't see just the. This worked a minute ago.
Yeah, correct. I don't know why it's before it was fine.
Oh, here we go. Oh, I think I know what it is. I shared. Hang on, let me stop and start again. Apologies.
No worries.
I got it right the last time and not this time.
The test worked.
Yes.
No, so that doesn't work. Okay, let's not worry too much. It's maybe because the screen sizes or something. Could be something like that.
You have to share the full screen to get it because you're sharing a different window when you're doing a presentation.
Well, that's what I thought, but that's what I thought I'd done wrong. But no, I didn't. I shared a desktop. Anyway. I think I might just have to work with this. I'm sorry. Okay. I don't have that many slides anyway, so I'll just work with this, I think. Anyway, thanks for joining. I just want to give an overview of the Trow project, which is Container Solutions open source on-prem registry that's designed first and foremost for Kubernetes clusters. So the Docker Hub was basically the first registry, and it's a Docker Hub that sort of gave you the magical experience when you type in Docker run Debian echo hello world for the first time, and Docker actually in the background would go and download and launch a Debian image for you, and all that wouldn't have been possible without the Docker Hub. So I really think the Docker Hub was a crucial part of the sort of the explosive uptake of containers. And the Docker Hub is still by far the best resource for getting curated, reliable base images like Debian, Alpine, Redis, Nginx, etc. But the Hub isn't so great for your own sort of private images, or private images to an organization or a person, or ones that you want to run local to a cluster and aren't intended for use outside of your organization. And for that reason, most of the major, well, all of the major cloud providers have their own registry service. So AWS have ECR and Google have GCR, etc. And the reason that they're so popular is they cut down on transfer time and costs, as well as they avoid the need to like integrate with a third party. So you don't have to employ a third party registry and figure out the authentication, etc., etc. But there are some third party vendors. The ones that I've seen are JFrog and Sonatype Nexus. I don't really know much about them, so I'm going to largely skip over them. But by far the most sort of popular non-cloud registry is the Docker registry, or Docker distribution as it's also known. And that's sort of the free open source Docker registry that you can run on-prem and is pretty reliable and works. But there is also VMware hardware. Well, it used to be VMware hardware. It's now a CNCF project. So it's completely open source now. But it actually builds on top of the existing Docker registry. And that's a very popular choice. But now, or very recently, we also have Trow. Now this is Trow's current logo. It does kind of need a new logo because I get like an optical illusion every time I look at it. Does everybody else see that? Like sometimes I see either points in or points out. So that's either like projecting out towards me or projecting away from me, and it confuses me. But anyway, yeah. So as we were saying, there's plenty of registry options. Why did we choose to build another one? And the reason mainly is that all the existing registries largely focus on being a complete archive. So they want to store all your images back in history, including all the development versions, all the testing versions, and everything you've ever done. But that's not necessarily what you want for your clusters. And Trow takes a very different view of things. And Trow looks at securely and efficiently delivering the working set of images to your cluster. And to define that working set, that's basically the set of images that's required to run your application and nothing else. So it's not the full history of all your images in time. It's not all the development and testing images. It's just the images you need to get your application up and running inside your cluster. It may also include 1 or 2 generations back for the reasons of rollback, but it's still much less than you typically store in a registry. So this led to a few considerations for the design of Trow. So Trow is designed to normally run inside a Kubernetes cluster. It will happily run actually standalone, but it's really meant to get the most out of Trow, you really want to run it inside a Kubernetes cluster. Now, there's no choice of backends in the Docker distribution sense of the word. So you can't save to like S3 buckets or anything like that. It just saves to the cluster hard disk and wherever that volume points to. Security and auditing is a major part of Trow. So we're really trying to focus on one being secure, but also offering like security features and auditing features. So the idea is to be able to look at the Trow audit log, and that would give you a good indication of what's happening in your cluster and what images are being run. It's also lightweight, unlike some other registries, however, that you may run into. And the idea is it shouldn't put any extra strain on the cluster to run the Trow registry. And because of this idea that it should be lightweight and also fast, we've actually written Trow in Rust. So it's a completely clean implementation of a container registry written in Rust. And Rust, again, ties back into security, and it's very reliable programming language that is also very efficient, and it's no GC pauses, etc. So what are the current features of Trow? One of the big things is we just managed to achieve OCI standard compliance, although the OCI standard tests are changing, so I actually need to rerun the test layer. And not many registries are actually OCI standard compliance because of usually minor issues to do with deleting images and things. It supports the catalog API, which is they're kind of going back and forward on whether or not that should actually be part of the OCI standard. Basically, a catalog API gives you a way to ask a registry what are the current repositories inside that registry. One thing that's unique to Trow is we've added a tag history API. So for any given tag, say you had an image Redis latest, you could ask it for the history of all images that have pointed to that tag. So if I call a tag history API, I would get back a list of SHA hashes that represent images that Redis latest has ever pointed at and the dates of which they were active, which can be very useful for auditing and figuring out what the changes that have happened in your cluster. We've also added some Kubernetes image controls. Perhaps most notably, there's a validation webhook, which allows you to control what images can run in the cluster. And it's really quite handy being able to tie that into a working registry, because that gives you some more controls and more information accessible to make those decisions. Okay, so what I really want to do is run a demo. There's two installation options for Trow. There's a quick install, and that's really meant for, you know, just trying out Trow or for like development clusters, things you don't really care about. But normally you would install Trow via customize, and you'd set up like a proper domain name or IP for it, and TLS, etc. But in this case, we're just going to use the quick install, which does use TLS as well, but isn't really intended as a long-term install. Okay. So, well, actually, one nice thing about being in this window is you should now see my console for the Google Cloud. So just before this talk started, I spun up, and there's a reason like I went off camera, was I spun up this Kubernetes cluster here. So I've not done anything at all to this cluster. I've not even connected to it yet. So it's a completely fresh Kubernetes cluster in JKE. I'm going to click connect, copy this. Do you see the terminal window? Just give me a thumbs up. Yep, cool. Yeah. So let's connect to the Kubernetes cluster and see what's there. Yeah, so that looks good. So we've got like a default Kubernetes cluster running Kubernetes 1.1.4. Seems kind of old. Okay. Right, we're in. So I have a checkout of the Trow repository here. So this is literally just what you can get by doing a git clone of the Trow repository on GitHub. And there's a quick install directory. And in here, there's an install script that I'm going to run. Now, if you read the install instructions, it tells you what it's going to do, but it also gives you this line. So one thing I know I need to do is make myself a cluster admin in order to be able to install Trow on JKE. So I'm actually going to Control-C out of that and run this command. That looks good. And I'll run the install script again. There's also this point about making sure port 31,000 is open so that clients can connect. My project's already set up to allow access on port 31,000, so hopefully I don't need to run that. Okay, so let's continue. Yeah, and it's going to install to keep public namespace. Okay, so that the first thing it goes and does is basically create the tripod. It also sets up a certificate, a TLS certificate, which it gets from the Kubernetes CA service. And for some reason, that takes a second before the certificate gets approved. I'm not really quite sure why. It just, I think it's just some timing within Kubernetes. So we have to give that a second. The awkward wait to see if it all works. And there we go. And that certificate gets copied to the nodes. One annoying thing about Kubernetes is Kubernetes nodes don't trust the Kubernetes certificate by default, which I feel they should, but they don't at the minute. And the next thing it's going to ask me is if I want to install certs on this host, as in my laptop, and configure etc host to allow access on this machine. And what that's going to do is basically allow me to do Docker pull and push to the Trow registry. That's running in JKE. So we're going to say yes to that. The last thing it asks me is if I want to configure Trow as a validation webhook. So this is the thing that I was describing earlier about being able to stop images from being deployed to the cluster, like from external repositories, etc. So I'm going to say yes to that as well. Okay, so that should be running. Go, we see the Trow deploy pod there. Okay, so the first thing I want to do is try and get something running. Try and push something to that registry. So I'm going to pull the Nginx Alpine image. I already have it, to be honest. I just want to show that it is just the standard Nginx Alpine image. And then we're going to tag it to this registry that's in this JKE instance. I will claim that this install script is probably about the fastest way to get a registry running inside a cluster. Okay, so I tagged it. I'm going to push it. I should have just copied the above line, but I haven't. Okay. Right, so that's pushing the image to the Trow registry. That's quick. So now that we've pushed the image, we should be able to create an image. We should be able to create a deployment that uses that image. So I'll just use the shorthand. Again, I should really be copying and pasting this because I'll make a typo. Okay, so we create a deployment called Trow test using this image from the Trow registry. Okay, that's created it. Let's see if it's running. This is a bit where things can go horribly wrong. I'm not going to try and pronounce that. Okay, yeah, it's running. So that's pretty good. So we know the Kubernetes cluster. So we now proved I can push images to the Trow registry from my laptop, and the Kubernetes cluster in JKE can also pull from it. And it got it up and running quicker than I was, able to type kubectl get nodes or get pods or get deploy even. Okay, so we also configured that validation webhook. So because I set that up, we can't actually deploy images from any other source other than the Trow registry. So if I want to deploy something to the cluster, it has to first be pushed to the Trow registry the way that it's configured currently. So for example, if I try to create a deployment that uses the Docker IO, the official Docker Nginx image, like this, looks about right, I think. And then I do deployment. We can see it's not running. Now, okay, at the minute that could just be because it's taking time to download. But if I do describe replica set proxy, yeah, we can see there's an error message here. And what the error message is saying is that admission webhook validator.trow.io, which is the validation webhook running in the Trow registry, it's denied the request. And what it's saying is you're not allowed to run the docker.io nginx image because it's not inside the Trow registry and it's not in the allow list. So you can create, reasonably complex lists of which repositories and registries you're allowed to pull from to in your Kubernetes cluster. To give you an idea of how it works, we can take a look at the logs. So the logs, when Trow starts up, it gives you like information on how it's being configured. This might be. I'm hoping tab completion will work here. Yep. I'm only interested in the start. Right. So this is what Trow is like given to the command line when it started up. And what it's saying is, well, that's the names of like this registry. So if an image is prefixed with this name, it understands it as coming from this registry. And these are the prefixes that are allowed. So by default, you have to allow kubernetes.gcr.io. I found out the hard way what happens if you don't allow that, and you won't be able to start Kubernetes pods because that's where, that's the image name of Kubernetes pods. So if you were to update a Kubernetes core image, suddenly things would stop working because the Trow registry wouldn't allow them to be deployed, which isn't what you want. It also explicitly allows the Trow registry itself and anything stored in the Trow registry. By default, if you've configured it as a validation webhook, then everything else will be denied. But you can explicitly allow images. You can also explicitly allow repositories. So I could say docker.io/library is allowed, and that would allow you to run any of the official images from a Docker hub, but wouldn't allow you to run random user images, for example. Okay, so that's the validation part. Another couple of things I want to quickly show you. I've added the -k command to curl here because curl otherwise won't recognize the certificate. In a proper install, you'd have a recognized domain name and recognized certificate, so you wouldn't need to do that. Okay, so there is the catalog API. This is actually part of the Docker distribution standard, but not part of the OCI registry standard, strangely enough. Hopefully that works. Yeah. So we've only pushed one repository so far, and that's test nginx. So that just gives you a list of all the repositories in the registry. The other thing we can do, and I talked about it briefly, was ask for the history of any image. So far, all we've done is push this nginx Alpine image. Let's try pushing a new version of that. What did I call it? Docker. So I'll need to pull another image. So that was nginx Alpine. There's an nginx Debian image. Well, let's just call it pull image nginx latest. Okay. And what I'm going to do is I'm going to tag that with the same name as my previous image. Well, actually, I can just do it. Control-R, Docker tag. And this is latest now, but I still want to use the old tag of Alpine. And then if I push that, so now we should have pushed a new version of this image. And if I get the URL right, I should be able to get the history of these images on that tag, if that makes sense. Okay, so it's not a curl command. Ideally, we'd have like a GUI that would make this a lot easier. So I've added this manifest history endpoint. The way you put the URL together is a little bit convoluted, but it follows basically this layout of other commands in the registry API. So that looks about right. So we're asking for the test nginx repository and the manifest history of the Alpine tag. Let's hope that works. Yeah. So what we're getting back is this is saying that it's pointing to two different images. Watch this. Why don't we? There we go. It's pointing to two different images with these separate SHAs. Both of them were today, but one is at 226 and one is at 220. And you can see how that could be useful, like in auditing and figuring out what's going on in your cluster. That's about it for the demo. I do have a couple of slides that that I want to finish up on, but is there any questions?
Yeah, I'll go. Is there any plans to have it work as a pull-through cache?
Yeah, that's actually what I'm working on at the minute, because I kind of see that as being critical to like how it works. Now, there are questions of exactly what you mean about a pull-through cache, but I very much see like Trow working alongside other repositories, which may be the Docker Hub, or maybe, you know, just some large central registry that you use that stores the entire history of all the images. And then you have Trow running in like a separate cluster where production images or, you know, or whatever are running, and they just store the working set. And so they would pull from the central registry and keep them in the Trow registry, if you like. And in that sense, it would be a pull-through cache. Now, the OCI standard, the OCI are looking at how this should be brought into the standard, and it's a little bit complex at the minute. So it's not entirely clear how we should do this at the minute. So if that's something you're interested in, I would actually be really interested to talk to you and find out how you think it should work.
Well, I can explain a bit about my use case, so I don't hijack the meeting here. But so I work as a SRE at Groupon, and what we do is we have our clusters are promoted on a blue-green deployment basis. So you know, if we deploy Trow into the cluster, it would get destroyed later on. We obviously don't want to keep doing that if that's meant to be your main repository of images. But we're also still split currently between on-prem and the cloud. So we have a Artifactory running on premises, and that's where most of our stuff is. And we always pull through from Artifactory. So, for example, you allowed docker.io through there. We actually had a production issue where docker.io was down. So we don't allow that. So we always pull through from Artifactory, but that is resulted in enormous bottlenecks and performance issues because we have like several hundred nodes will spin up at the same time, and that then tries to pull several thousand images at the same time. So Artifactory chokes, and you actually see delays of about 7 minutes from the first to last time of an image being asked for and downloaded. So I'm extremely interested in having something that goes into the cluster and so that it shortens the network path for all the nodes. So at boot time, they're talking to that rather than trying to talk back to on-premises. But having to configure that like the way the Amazon registry is, where we have to push everything to the registry, is going to be painful. So we'd rather do it like it could just pull it through from the Artifactory cache as needed. That's it.
No, that's pretty much exactly the kind of thing I'm looking at, and it also ties into something else that I want to. I have a couple of slides on like future plans, and it ties into a couple of things there. So one thing that confused me slightly, you're saying you're doing blue-green, but it sounds like you're doing blue-green on like the whole cluster level. So you completely kill one Kubernetes, well, not kill, but turn off one cluster and switch on another cluster. Is that right?
Yeah.
Okay, that's pretty cool. Most people that say they're doing blue-green don't actually do that. They just do it at like the individual service level, which I argue isn't proper blue-green. But
it's kind of controversial. We've had long-running arguments for the last couple of years about this because the reason we do it is because you know, whenever you try to promote to upgrade a cluster, you're always at risk of taking the cluster down. So you have to worry about, you know, how do we survive that? And our real problem has been that because our on-premises is in Northern California, we have to use the US West 1 region in AWS. And if any of you have actually used AWS US West 1, you'll know there are only 2 AZs there. So you can't have your quorum split across 3 AZs. So suddenly the entire thing becomes really a nightmare to try and keep stable. So what we've done so far is to basically just bring up a cluster in the background, migrate data, then migrate traffic, and then tear them down. And that's how it's worked for the last 2 years. But I've been arguing that we should actually go to a cluster per AZ model, so that we actually can then, because we have multiple clusters up, it becomes less risky to just promote in place. So you just upgrade and hope it works. If it fails, who cares? We tear it down and spin up another one.
Okay, that's really interesting. Yeah, it might be worth following up later. I don't know if I have your email or whatever, but we'll figure something out.
Earlier on, I was the one who sent you the Highland Bookshop.
Oh, really?
Yeah.
Oh, yeah, cool. Yeah, I know who you are. Okay, great. Oh, I'll follow up with you. That'd be cool. Any other questions? No? Okay, I'm going to go up to my wrap-up slides. Oh, this is working now. I just didn't have the right window up. Well, that's really annoying. Now we can go through them all again. Oh, so it does work. I've gone past it, right. So what I just wanted to say was there are some sort of planned features for the future. One of the ones that I'm really sort of keen on is the idea of vulnerability scans. So this would be an integration with something like Trivy or Claire, or well, actually probably either, because there's actually a standard for how you can do things now. Or Harbor created a standard for vulnerability plugins to use. And the idea basically is for any image, you could ask Trivy or Claire if there are any known vulnerabilities associated with that image. Potentially stop images from being promoted to production if they have critical vulnerabilities, for example. I think we really do need a GUI just for simple administration tasks and operations, and also give an overview of what's happening. And that ties into the point about a full audit log for being able to tell you sort of the status of images and the history of images that are running the cluster. And immutable tags. So that's the idea that if I push an image to a given tag, it can never change. And actually Kubernetes kind of runs on this idea anyway. If you try and update an image but leave the tag the same, bad things kind of happen and you end up with nodes that are running different versions of the same image and things. So Kubernetes really does inherently think tags are immutable anyway. So I really want to be able to identify certain tags as immutable. The last thing I want to mention is ahead of time image distribution. So if you've looked at things like Kraken or Dragonfly, these sort of use P2P mechanisms to quickly transfer images within a cluster. And I kind of want to look at something simpler for Trow. So Kraken and Dragonfly are used on enormous Kubernetes clusters. It's used by Alibaba and Uber, where they have ridiculously large clusters. But I would like to look at create something simpler, but has the same effect, whereby images get transferred to the nodes that need them before they need them, so that you can start up containers much quicker than you can at the minute in Kubernetes. Yeah, and that's pretty much it. Are there any more questions? No, okay. So if anybody wants to get in contact with me, yeah, please just tweet me at Adrian Mouat. The Trow website is trow.io, and there's a GitHub page at containersolutions/trow. Okay, thank you very much for listening. Teresa, is there anything else you want to add?
No, thank you a lot, everyone, for joining. You can see on our website we are organizing more of these sorts of events. So if you are interested, you can join. We have at least 1 or 2 every week. So please feel free to register. Otherwise, yeah, nothing more. Thanks, everyone.
Thank you all.
Thank you. Bye.
Thank you so much.
Bye.
Bye. Stay safe.